we are working limits and solving them analytically. We have one here that involves some exponential function. Okay, so first thing we're going to do is the direct substitution, plugging the natural log of 2 directly in and seeing what we end up with. So I'll just rewrite that right here. So put a little equal sign. I'm going to throw the natural log of 2 right in where this x is. And then do the same thing down here in the denominator. Alright, the law of natural logs is you can take this coefficient here, this 3, and bring it out up here as the exponent up here in the 2. And so this becomes the natural log of 2 to the third power, and the natural log of 2 to the third power is the natural log of 8. So we end up with e to the natural log of 8 minus 8 over, and then we're going to do the same thing down here. You can bring this 2 right up here, and so this becomes e to the natural log, and this would be 2 to the fourth, which is 4. Natural log of 4. Now you need to know the properties of the natural log and how they're related to e. We're not going to get into that. But if I have e raised to the natural log of 8, this stuff here kind of falls away, and you end up with 8 minus 8. So you'd end up with 8 minus 8. So e raised to the natural log of 8 is just 8. And then the same thing goes for down here in the denominator. E to the natural log of 4 is just going to be equal to 4. And so what we're going to end up getting here is 0 over 0. So our limit is going to be equal to 0 over 0. So we need to do some factoring and canceling some stuff out here, try to simplify this down. I'm going to rewrite this. So let's just go back down here and rewrite everything here. So we have the natural, well, we don't have the natural log. Let me get rid of that. We have the limit as x approaches the natural log of 2. So up here in the numerator, we're going to end up with e to the x. And I'm going to rewrite this. This is all raised to the third power. Minus, and then we had 8, and that's the same thing as 2 to the third power. Now this is in a form here where we can factor, and we did some of this earlier. Except just pretend this is all x here. X cubed minus e to the 2 cubed. And then down here in the denominator, we've got e to the x. And that's all squared minus, and we could say 2 squared here. So there was a formula that we kind of used here to factor that top part. And this bottom is just the difference of 2 squares. But we rewrote the e to the x minus, we take this sign here, rewrite it, and we take the 2, rewrite it here. Then we have e x, and then this is all squared here. So this was like x squared. I guess I'll just go ahead and do it like that instead of writing 2x. Okay. And then this sign here, because this is a minus, we wanted to always put the opposite here. And then we end up having 2, just taking this number here, and then e to the x. And then this is always going to be a plus here. And then we square this number, which makes that a 4. Okay. And that's all over. And I'm going to go ahead and factor this bottom part. So this is e to the x minus 2 times e to the x plus 2. Alright, now we can find some stuff in the top that maybe looks like something in the bottom. Well, we have e to the x minus 2 and an e to the x minus 2, so we can cancel those out. And we might want to rewrite this limit here. Let's just go ahead and do that. Now I'm just going to go ahead, this is 2 times x plus 2e to the x plus 4, and that's all over ex plus 2. Okay, so now what you want to do is go ahead and do the direct substitution now, plugging the natural log directly in, the natural log of 2. So we end up having e to the 2 times the natural log of 2 plus 2 times e to the natural log of 2 and let's see here, plus 4, and that's all over e to the natural log of 2 plus 2. So remember, you can take this 2, you bring it out here, so this is 2 squared, okay, and which is going to end up being 4 plus, and then this is going to end up being e to the natural log of 2, which is going to end up being 2, and then 2 times 2 is 4. So I think we're almost there. And then this is 2 plus 2, right? So we end up with 12 over 4. And that's going to end up equaling 3. Alright, finally. So let's go back up here. And we can now say that our limit is equal to 3.